The loss of body hair is one of the most distinctive features of the human species. Among the great apes, humans are the only truly hairless primates, an evolutionary mystery that touches on genetics, climate, cognition, and culture. While modern humans retain hair on the scalp, the rest of the body is sparsely covered compared to our primate cousins. How and when did this hairlessness evolve? What genes were involved? And how does it connect to the dramatic expansion of the human brain, the use of fire, and the first uses of animal hides and sexual selection? New genetic, archaeological, and anatomical evidence suggests that the path to hairlessness was not a sudden leap, but a mosaic process involving overlapping evolutionary pressures. By 1 million years ago, this transformation was essentially complete. Early humans had become sweat-cooled, fire-warmed, skinning-savvy predators whose naked bodies were unlike anything the world had seen. Hair growth in mammals is controlled by a complex network of genes, regulating follicle development, cycling, and the production of keratinized proteins that form the hair shaft. In humans, several key genes have undergone modification, mutation, or outright inactivation, contributing to our loss of body hair. One of the most important genes implicated in human hairlessness is KRT41P, located on chromosome 17. This gene is part of a larger family involved in hair shaft formation. In chimpanzees and gorillas, this gene is fully functional and contributes to the formation of thick, coarse body hair. But in humans, a single nucleotide deletion renders the gene a pseudogene. It no longer produces a functioning protein. This genetic disruption is estimated to have occurred between 800,000 and 1 million years ago, based on molecular clock analysis and comparative studies with Neanderthals and Denisovans, both of whom inherited the same non-functional variant. The inactivation of KRT41P is a smoking gun in the story of human hairlessness. Once this gene was lost, it would have been nearly impossible to regrow thick body hair. Evolution rarely rewinds. The irreversible loss of this gene marked a point of no return, genetically locking our lineage into a future without fur. Other genes reinforce this trend. The hairlessness gene, HR, a master regulator of hair follicle cycling, also shows signs of modification in humans. Likewise, regulatory genes like LHX2, which help maintain follicle stem cells, appear to have lost certain enhancer regions unique to humans, meaning that although hair follicles still form, they are thinner, less active, and less uniformly distributed than in our ancestors. But why would humans lose their hair in the first place? Hairlessness, it turns out, is intimately connected to another evolutionary hallmark of humanity, our enormous brains. The human brain is metabolically greedy, consuming up to 25% of the body's resting energy. As our ancestors evolved larger and larger cranial capacities, beginning with Homo erectus around 2 million years ago, the need to dissipate heat from the brain became paramount. Hair, which traps heat, became a liability. Humans evolved a new cooling system, eccrine sweating. While other primates rely on panting or sparse sweating through apocrine glands, humans developed a dense network of sweat glands across the entire body. Sweating through naked skin allows for more efficient evaporative cooling, enabling long-distance running and reducing the risk of heat stroke during active foraging or hunting. This thermoregulatory advantage would have been especially important in the open savannas of East Africa, where Homo erectus first appeared. As our ancestors began persistence hunting, chasing prey over long distances until it collapsed from exhaustion, the ability to cool the brain during sustained exertion may have directly enabled the expansion of neural tissue. The brain and the skin were not evolving in isolation. They were part of a coordinated shift in human biology, where losing hair meant gaining the thermal freedom to grow a bigger brain. This idea is reinforced by the timing of the loss of the KRT41P gene. Around 1 million years ago, brain sizes in Homo erectus had already reached 900 to 1100 cubic centimeters, nearly double that of earlier hominins like Australopithecus. Evolution was solving one problem by creating another, and solving that too. With less hair came a need for protection from cold, and that solution would be cultural, not biological. If early humans lost their hair in Africa, How did they survive the cooler temperatures of Eurasia after migrating out of the tropics over 1 million years ago? The answer is fire. The oldest well-supported evidence of fire use comes from Wonderwork Cave in South Africa, dated to 1 million years ago. Here, archaeologists discovered burned bones and ash layers deep inside the cave, far from any external fire source. Microscopic analysis confirmed that the material had been exposed to controlled, low-temperature burning. This was not the result of a brush fire, but deliberate fire use. Around 780,000 years ago, at the site of Gesher Benot Yaakov, charred plant remains, burned flint tools, and spatially distinct hearth-like clusters point to repeated fire use in a riverside camp. These fires were not only for warmth or cooking, they created social spaces where knowledge, tools, and possibly hides were shared and prepared. And that brings us to the next key adaptation: animal hides. An article from Live Science describes new insights into the lifestyle and technological abilities of Peking man, a population of Homo erectus that lived between roughly 500,000 and 750,000 years ago. Through the use of microscopic wear analysis on stone tools from the Zhoukoudian site near Beijing, scientists have discovered that Peking man was far more sophisticated than previously assumed. The tools show evidence of being used to shape wood, indicating that Peking man engaged in woodworking. Although no wooden artifacts survived, the wear patterns strongly suggest activities such as sharpening sticks and possibly constructing wooden implements. According to the article, Peking man was a woodworking, fire-using, spear-hafting hominid who, mysteriously, liked to drill holes into objects for unknown reasons. This quote captures the surprisingly versatile nature of these early humans, including their use of fire, which is often considered a major technological milestone. One particularly striking discovery is that Peking man hafted stone tips onto sticks to create spears. This would have required a combination of materials, such as adhesives or bindings, and a clear understanding of how to construct compound tools. The tools also show signs of deliberate shaping and edge sharpening, further supporting the idea that Peking man had mastered complex tool-making techniques. Another remarkable detail is the presence of wear marks on tools consistent with scraping animal hides. This suggests that Peking man may have made and worn clothing. Researcher Chen Shen explained, a certain proportion of tools were being used for the working and scraping of hides. He went on to note, if they are depressing the hides, if they are softening hides, they can use the hides for their clothes, something no sophisticated hominids would dare live without. Perhaps most enigmatic is the observation that some tools appeared to have been used to drill holes into various materials. The purpose of this behavior is still unclear. The article simply notes that Peking man liked to drill holes into objects for unknown reasons. Whether this was functional, symbolic, or even decorative remains a mystery. In summary, the article paints a picture of Peking man as a technologically adept hominin with capabilities well beyond simple stone flaking. Their ability to manipulate fire, shape wood, construct tools, and possibly even wear clothes suggests a degree of cultural and technological sophistication that brings them closer to modern human behavior than once believed. The loss of hair required early humans to find other means of insulation, especially as they spread into temperate and cold regions. Archaeological sites like Taubach in Germany, dated to approximately 400,000 to 300,000 years ago, contain beaver bones with delicate cut marks around the tail, limbs and pelvis, patterns consistent with skinning for fur rather than meat. Beavers are small, difficult to catch, and have rich waterproof pelts, ideal for wrapping the body. At Schöningen, another German site from roughly 300,000 years ago, wooden spears were found alongside horse and bear bones with cut marks in anatomically telling locations. In particular, bear paws show incisions not associated with butchery, but with the careful removal of hides, precisely the kind of labour that would go into producing a warm pelt for a cold night. While direct evidence of clothing is lacking, animal skins don't preserve well, indirect evidence is abundant. Tools with microwear polish from hide scraping, bones with skinning cuts, and the strategic selection of fur-bearing animals all point to an early use of hide.
If we were to subscribe 100% to the idea of survival of the fittest, isn't it illogical to think that all of a sudden we're completely naked and we're losing all of our fur? I mean, that makes absolutely no sense, because right after we shed our fur, we had to wear furs to keep warm. Had we not worn any furs, we would have frozen to death, we would have died. So the whole idea that we shed all of our hair in order to survive because we were stronger, logically, makes no sense.
By 1 million years ago, the basic biological and cultural machinery of human hairlessness was in place. Genes like KRT-HAP1 had been shut off. The shift to sweating-based thermoregulation allowed humans to expand into hot, open environments while supporting larger brains. And early fire use began to fill in the gaps, providing warmth, light, and a platform for culture. Crucially, early humans did not respond to the loss of body hair by re-evolving fur in cold climates. Instead, they adapted behaviorally, building shelters, using fire, and wearing hides. Evolution found a faster path through ingenuity and learning rather than rewinding genetic history. The skin, once hidden beneath a coat of fur, became a new frontier. It allowed for the development of melanin-rich pigmentation to protect against UV damage. It facilitated social signaling, with sweat and pheromones replacing musk and fur in communication. And it marked the beginning of humans as tool makers, not just of stone, but of their own bodies and environments. When we look back at the evolutionary arc of human development, it becomes increasingly clear that the transformation to a hairless body was largely complete by the 1 million year mark, at least in the direct line leading to Homo sapiens, Neanderthals, and Denisovans. The inactivation of key genes like KRT-HAP1, the expansion of the eccrine sweat gland system, and the parallel increase in brain size all point to a profound physiological shift. Homo erectus had by this point become a naked biped adapted to long-distance running, endurance hunting, and complex social dynamics. Fire was now in use, hides were being processed, and cold was countered not by regrowing fur, but by invention and cooperation. But this was not the only hominin story. The ancient world was never inhabited by just a single lineage. For millions of years there were multiple types of hominins stomping across Africa, Asia, and eventually Europe, each adapting in its own way to its environment. Not all of them are our ancestors. Some were cousins, some were evolutionary experiments, and some, though extinct, challenge our assumptions about what it meant to be human. Australopithecines, for instance, such as Australopithecus afarensis, likely retained much of their ancestral body hair. Their smaller brains, arboreal adaptations, and tropical woodland habitats suggest that thermoregulation through sweating was not yet the dominant evolutionary pressure. They walked mostly upright, but they were still wrapped in fur. Even more recent hominins like Homo naledi, whose fossils were found deep in the Rising Star Cave system in South Africa and date to only around 300,000 years ago, likely retained body hair. Despite their surprisingly recent date, Homo naledi had small brains and a mosaic of primitive and advanced traits. With no clear evidence of fire, tailored clothing, or long-distance migration into colder climates, there was no obvious selective pressure for them to lose their fur. On islands in Southeast Asia, Homo floresiensis survived until as recently as 50,000 years ago. These diminutive hominins likely also retained hair. Living in a humid rainforest environment with small body size and no apparent use of fire, they did not require the naked skin and sweat-based cooling system of their mainland cousins. In fact, in tropical forest environments, hair may have remained advantageous, helping to protect against insects or reduce skin abrasions in dense underbrush. Perhaps the best example of early humans who almost certainly retained body hair is found in the Dmanisi hominins of Georgia, dated to around 1.77 million years ago. These individuals, belonging to an early Eurasian population of Homo erectus, or a closely related species, lived in a high-altitude, seasonally cold environment. Yet there is no clear evidence that they controlled fire, used clothing, or processed hides. Their tool technology was simple: alderman-like flakes, and they relied on scavenging and short-range hunting. Without fire, without tailored hide garments, and without the metabolic demands of a greatly expanded brain, they almost certainly needed fur to survive the cold. In all likelihood, they still had body hair despite their migration out of Africa. So while the evolution of hairlessness was underway by the time Homo erectus emerged, it did not happen uniformly across the hominin world. It was not a shared destiny. It was a path taken by one branch of a complex family tree, one that led to Homo sapiens, but not to everyone. The world of the past was populated by many kinds of humans, hairy and naked, small-brained and large-brained, tool-makers and climbers, tropical foragers and ice age hunters. Evolution did not favor one strategy, it experimented with many. What distinguishes our lineage is not merely that we lost our fur, but that we replaced it with a suite of cultural innovations, fire, hides, cooperation, that allowed us to thrive without it. Where others may have remained tied to biology, we became the species that modified our environment. We became the species that learned to wrap a deer skin around our shoulders and step into the cold night without flinching. By 1 million years ago, Homo erectus had committed fully to this new path. There was no going back to fur, no turning away from the naked skin that demanded new solutions and rewarded innovation. In the cold, they built fires. In the rain, they wore hides. In the heat, they sweated and ran and thought. Hairlessness, then, is not a quirk. It is the foundation of a feedback loop between biology and culture, skin and fire, loss and invention. It allowed our ancestors to become the first truly adaptable species, rooted in biology but liberated by behavior. To understand when we became human, we must not only ask when we stood upright or made tools. We must ask when we stood bare under the sun, cooling our minds, wrapped in smoke and skin, thinking. That moment, naked and brilliant, happened by the dawn of the Middle Pleistocene, when we lost our fur and began to burn. When we look back at the evolutionary arc of human development, it becomes increasingly clear that the transformation to a hairless body was largely complete by the 1 million year mark. The inactivation of genes like KRT-HAP1, the expansion of the eccrine sweat system and the concurrent rise in brain size all point to an integrated physiological response to new environmental demands. Homo erectus, by this point, had become a naked biped adapted to long-distance travel, thermoregulated endurance hunting, and social interaction in large mobile groups. But nature did not leave this new vulnerability unprotected. What evolution took away in fur, human culture replaced with fire, shelter, and skin. Fire itself was not merely a source of warmth, but a catalytic force in human evolution. It extended our days, protected us from predators, made meat digestible, and dried the hides of slain animals. Those hides, carefully skinned from beavers, bears, and deer, were the first steps toward clothing, long before weaving or sewing existed. They were draped, wrapped, or fastened with bone and sinew, transforming a biological loss into a technological advantage. In these primitive garments, we see the first outlines of humanity's ability to transcend the constraints of its own body through culture. By 1 million years ago, Homo erectus had committed fully to this new path. There was no going back to fur, no turning away from the naked skin that demanded new solutions and rewarded innovation. In the cold, they built fires. In the rain, they wore hides. In the heat, they sweated and ran and thought. Hairlessness, then, is not a quirk. It is the foundation of a feedback loop between biology and culture, skin and fire, loss and invention. It allowed our ancestors to become the first truly adaptable species, rooted in biology but liberated by behavior. To understand when we became human, we must not only ask when we stood upright or made tools. We must ask when we stood bare, under the sun, cooling our minds, wrapped in smoke and skin, thinking. That moment, naked and brilliant, happened by the dawn of the Middle Pleistocene, when we lost our fur and began to burn. Thanks for watching, and please leave a comment.